Hello. In this video, I'm going to go over how to sort of apply the calculations that we all did based on your design head and the Weir height that have been given to you. Okay. A lot of the dimensions I'm going to be using are going to be different from the ones that you're going to be given. In fact, all of them are. But I will be using this same style. I realized that as I was making this, I made my design head, um, to be something like four and a bit inches. Um, but the problem with that is, you guys will all have to print these yourselves, and it's going to be a lot to print if you guys have your design or your weir height above 2 inches. And I'm making mine 4 inches for this particular lab. And I will be going kind of back and forth between English and standard units, sort of an added challenge that, and hopefully it makes it so that, yeah, makes it harder to cheat that way. Maybe I don't know. So what I'm going to be doing is getting into SolidWorks here. All right. So yeah. Well, actually, first we'll start with your equation. So I'm not going to show you how to do these equations. I talked about that in the lab manual. But what I will show you is the outputs from my MATLAB. Okay, so this is the back profile of the Weir. I chose to plot it like this. I gave a couple of different options of how you might plot it. And if you notice something about this graph, it stays 1 to 1 and it's like a uniform scaling. Okay. So no matter how big I make it, like the aspect ratio stays the same and the relative length of the X and Y axis, stays the same. So if you got a ruler and you checked on these, like 0.1 or like the distance between 0.05 and zero point 0.1 on this axis would be the same on the other. Okay. So it's important that you do that. And you could use Excel to output this as well. I chose to use MATLAB. I think MATLAB is kind of the way to go for this. I'm not exactly sure how to scale how to keep uniform scaling in the graphs on Excel, but I'm sure it's relatively easy like it is on MATLAB. So anyways, this is our profile. So what I'm going to do first is I'm going to grab my snipping tool and we're going to capture this. Okay, where did my snipping tool go? Now I have the snipping tool open in another window. What I'm going to do is make a new snip. And it really only just has to encapsulate the curve part of the graph. Okay, cool. So once I have that screenshot, I will X out of my MATLAB graph. All right, so once we have the screenshot, we'll open up SolidWorks and we will make a new part. Okay, so new part file. All right, so the first thing I'm going to do before we use our sketch picture is we will model the front geometry. So I'm going to make a center line. So what I just did there is I hovered over the line tool here. There's a drop-down menu from the line tool and allows me to select a center line. So yeah, oh, didn't want to do that. So yeah, do the drop-down from the center line, from the line tool, grab the center line. We'll go to the origin here. Okay, click down on the origin. That's usually a great place to start. And then we'll go vertically up from the origin. Okay, so as you can see, this has that vertical icon. And as I was sketching it, it had that like, vertical line icon. And that means it's vertical. So anyway, I'm going to make this, my particular Weir height was 4 inches. So we're going to make that 4 inches there. Okay. Now we could go on to make the front geometry. Okay. So let's start to do that. So we're gonna make some arcs. I guess it'll be helpful. Yeah. So before we make the arcs, let's make a quick little center line here. Okay. Doesn't really matter how long this is, but I always like to fully define everything. So we're just gonna make it 2 inches, whatever. So now the line is black and we could see that we have the fully defined thing here. It's always just good to have a fully defined sketch. Okay, so now we will make a tangent arc. So we're going to make one tangent arc going from here down to about there or so, something like that. Okay. Then we're going to make another arc that's tangent to this one, and we'll make it something like that. Okay. From there, we'll be able to make a vertical line down. Okay, making sure we have the yellow vertical icon. I'm going to drag it down until I have that white horizontal icon. I'm going to click down, and then I'm going to go back to the origin where we started. Okay, so now we will dimension these arcs that we just put in. As you can see, the first one was tangent with the other one. And as you probably will have seen from the publications, this point here is now going to be coincident with that line because this arc is tangent with this line. Okay, and this point here is going to fall along the line of action from the center point of this arc to the end point of that arc where it's coincident with the next arc. Okay, so that and of course that means both of these are tangent as well. Okay, so if we refer to our documentation, we can see the dimensions that these things are supposed to be. Basically, they are all equations based on your design height. Okay, my particular design height was 0.1074. That's what it ended up being. 0.1074 meters. So that's how I will put all these in. Okay, so let's dimension this. So this one here is going to be that's equal to half of your design head. So you can make this point 1074 meters. Okay. Divided by 2. All right. Cool. And so that gives the position of that arc. And then we're going to dimension this one, and we're going to make it 0.1074 meters times 0.2. Okay. Yep. There we go. And that gives you a 0.85. Now, what we could do then is we could dimension the distance from this line here to this line here, and we're going to make it 0.1074 times 0.282. Okay. Oh, sorry, I forgot to say meters. Let's try that again. 0.1074 meters times 0.282. All right. Great. Okay, that looks a lot better. So great. Now what we can do is we can position this point here. Okay. Well, actually, let's do this instead. Let's go from this point to this point. Okay. And that should be 0.1074 meters times 0.124. Okay. Great. Cool. So as you can see, everything is black now, meaning that it is fully defined. Okay. So that's great. Now we have that geometry. I'm going to stay in this sketch. I'm going to exit the Smart Dimension tool, hitting escape. Okay. So we've made the front half geometry. And that's awesome. All right. So next, what we're going to do is we're going to go to tools. We're going to go to sketch tools. We're going to go to sketch picture. Okay. And then I'm going to go to, screenshots. We'll go all the way down, and we will go to that one there. We'll open it up. Okay. And now we need to rotate this 90 degrees. I need to go back the other way 90 degrees. So this is going to be 270. Okay, cool. So now what I'm going to do is I'm going to scooch this over. Okay. Well, before I go crazy with that, what I'm going to do really quick click check on the sketch picture to sort of get out of it. We could double click it to get back to that same mode, and we'll do that in a second. But what I need to do is I need to add a line at the bottom of the weir here. Okay, so something like that. That'll give me a sort of guideline as to where, and we'll get the length all sorted out in a second here. But that's a guide to see where this point down here is going to end. So right now, I'm going to scale this such that that point there starts here, and the bottom point of the graph where it intersects this sort of limit here. It's not an axis, but yeah, right at this point here is where I want it to intersect with this line. Okay, so first we could double click this. I happen to know that at like 7.5 inches in length, it ends up being pretty well scaled. Obviously, you guys will have to do some finagling to figure that out. You might ask, oh, it needs to be a little bit bigger. So let's make it seven, or sorry, eight. Let's try that. Okay, let's try nine. Okay, so that's going to be close enough. As you can see, it does sort of go a little bit past that line. So and that's okay. Like as long as it's like very close, then that's good. So we could go a little bit shorter, so we could try 8.9. And then that, yeah, I mean that looks pretty dang close to me. Okay, so that's going to be close enough. So we'll go with that. Uh, and we'll click check. Okay, now we're going to use this as a guide to make our curve. So once we have it positioned, we could go about making a curve that matches this. It can be said that, yeah, you might say that this method is a little bit rudimentary, and there are other ways of doing this. For instance, instead of just using a regular spline here, so you have the line tool up here, you also have the spline tool. The spline tool has a drop down, and as you can see, you can fix an equation to a curve. So yeah, you could put in your x and y dimensions as the equation, but as this point is here, like, and it's not quite an x and y, and there's like an intercept here. It's a little bit weirder than plotting it in MATLAB and then rotating it, in my opinion. To me, it's a little bit more complicated to input the equation. It's probably slightly more accurate, but at this point, it probably doesn't matter so much. But yeah, if you wanted to, you could go ahead and try and use an equation curve. But I recommend doing it like this. So basically just grabbing the spline tool, starting at the endpoint of the arc that we made, and just clicking on the curve within the picture about 3 points, including the endpoint on our line there. Okay, and then we could hit escape. All right, so now what I'll do is I will, at that point here, I will fix it. Okay, and I will also fix the other points here as well. Okay, there we go. So fixing those points. You might ask, why didn't I just fix the curve? And that's because it gives you an over dimension error because you've dimensioned that. So I tried to avoid that. Feel free to do that if you want an example of how that all works. But as I'm looking at this now, I'm actually noticing something. So we need to make this match a little bit better, or I would like to see it match a little bit better. So I'm actually going to remove the fix for the time being. So if you click the point, you should be able to see the icon. You should be able to click on it and press delete. Okay, and I should be able to shimmy this around such that it gets on the line, maybe in combination with both of these. So I'll unfix both of these guys, and we will keep trying to get it to match perfect, or at least close. Okay, that's a little bit better than it was. So you could certainly finagle it. The more points you put, the more accurate it'll kind of be. But I'd say 3 or 4 points is like all the accuracy you really need. Okay, so that's good. So now I'll go back and I'll fix those once again. Shift click, fixing both of those. Okay. Um, all right, cool. So now we have that shape mostly mapped out. Okay. The last thing we're going to do two more things for it. But we need to make a transition from this from out here to there. Okay. So we're going to keep this line a little bit long for now. Okay. But we will like fully dimension it eventually. Okay. So what I'm going to do next is I'm going to make a 3-point arc. So I'm going to go to the arc tool here, which is directly in the center. I'm going to go do the drop down from it. We're going to do a 3-point arc. Okay. One of the points is going to be on here. The end point is going to be the end point of that line. And the third point we could just put somewhere in there for now. Okay. So now we're going to only do a couple things to this. For one, we're going to make this guy and this guy tangent, okay? And we're also going to make this guy and this guy tangent. Okay, now in the picture that I gave you guys from the publication that I read to learn how to do all this, it gave a number of dimensions for this. The important one is to me the radius of this curve, okay, which is a quarter of your Weir height, which ends up being for me 1 inch. Okay, so yeah, since I made this curve and this line tangent, as well as this curve and this curve tangent, and I dimensioned the radius, and we know this line is horizontal, yada yada. That like sort of a combination of things makes this whole thing fully defined. Even though I didn't dimension this point specifically, it's it's defined from all the other dimensions and relations that we've made. Okay, so we made that transition. You might see that in the publication it asks for like a 30-degree arc, or sorry, 60-degree arc. At Weir's of this scale, I found that it gets a little bit weird when you have that 60-degree angle. But the most important part from that, geometry, in my opinion, is that they are tangent and the arc is smooth enough for the height. Okay, and it's smooth enough. It's smooth enough if the radius of it is a quarter of the Weir height. All right, so put 1 inch for there. So I put 1 inch for there, obviously, because I have a 4-inch Weir height. All right, so enough rambling about that little tail. Now we're gonna make another section for this Weir, and this one is a little bit kind of confusing. It's kind of hard to explain unless you see the Weir in person. Okay, or at least unless you see the experiment in person. But there's a large hole underneath, which we need to cover. Basically that hole allows us to put the weirs and fasten them to the bottom of the open channel lab. But we need to make an extended lip here so that the hole is fully covered. Okay, and I chose to do it this way. I'll show you in a minute how we plan to mount this, but basically we're going to use a nut that is semi-captive inside our print. Okay, and then we're going to screw a threaded rod into that so that the weir will be held down and it doesn't float downstream with the current. Okay, so okay, so now what we need to do is we need to make a sort of front lip geometry to this. Yeah, so as this sits at the bottom of the channel, it's bolted down through this hole that sits underneath it. And so we need to make a lip so that it fully covers that hole. That hole normally has a plug. So we'll come out from the bottom, okay? We'll go directly horizontal, okay? We're gonna make a triangular looking thing, but we're actually gonna give it a little bit of a vertical piece there so that it's stronger. If you make it go down to just a perfect wedge like that, it'll not be that strong, and it'll kind of let water in. It should be said also that we will have a rubber gasket underneath to hopefully seal it a little bit better. But even still, you need to make this strong enough. So we're gonna dimension that. We're gonna make it 0.625. Okay. Yeah. So one of the reasons also, if you're wondering why I'm even making this lip here and why don't just sink the like sort of put the nut in further. Well, you could do that, and you'd position the hole from underneath to be a little bit to the right on screen. But yeah, it's just kind of hard to wedge that bolt in there quite so far. So yeah, that becomes a little bit difficult. So I want to avoid that a little bit, and so the compromise is to sort of make this small wedge out front. So we're going to make this. You could make it pretty small. I'm going to go with 0.075. You could do zero point 0.1 as well. And then I'm going to make it very small here to be point point two. Let's do. And yeah, I'm not gonna like simulate this, but I'm just trying to make this like really, really small so that hopefully it doesn't really affect what we've done over here. It probably does, so you need to write about that in your lab report. If you do want to, you could try for the method where it submerges your nut a little bit farther. You just have to back your hole up, this distance, 0.625 of an inch. So, anyways, yeah, that looks pretty good as far as our geometry goes. Now we're going to exit the sketch and we're going to go click the sketch once again. We'll do boss extrude. Okay. We're going to make this 105 millimeters. Okay. And we're gonna click all the features. Make sure you get your little swoop there. Okay, that's looking pretty good. So I gave you a channel width of 0.11 meters, which is 110 millimeters. But in actuality, the channel has a little bit of a taper, unfortunately, and just to make it easy to like just stick it in, it's nice to make it a little bit narrower than the channel, and you don't really lose that much flow around the sides if any at all. I would say so. Yeah, so we made it a little bit narrower than the channel by it's 5 millimeters narrower than like I tell you, but in actuality, it does get pretty snug towards the bottom. So yeah, that should be good. Okay, now it's time to put our hole in. Okay, so now what I'm gonna do is I'm gonna put the hole that rod is gonna come up and attach to, or yeah, and go inside of. So let's well actually we're not gonna do, yeah, let's do that. We're gonna sketch on the bottom. So sketch here. We're in the sketch, we're gonna do the line tool, drop down, get the center line, and we are gonna grab the midpoint there. So if you see there's that yellow dot in the middle of that like sort of edge, I go to that dot and now it becomes that icon with the two lines coming from it rather than the three. So that's like a midpoint coincident. Drag it out horizontal. I get the yellow icon indicating I'm horizontal. And then we're going to smart dimension that to basically we want this center of this hole to be a quarter inch past the face of the face of the sort of weir here. So we're going to do 0.25 plus the lip dimension, which is 0.625. So I made in the previous geometry a minute ago. Okay, cool. So we have the position of the hole now. That should be all we need for this sketch. So we're going to exit. And now we're going to go to Hole Wizard. So features, Hole Wizard. And then we're going to, instead of an 1/8 inch hole, which it pre-selected for me, we're going to go down and we're going to do a 0.26, too far, 0.261 hole. We're going to do a G. And then we're going to go to that point that we just made before. Oh, I need to click on it twice. There we go. And then, oh, I'm sorry. Let's go back to type. And we're going to make, instead of through all, we're going to make it blind. And we're going to go, yeah, 1 inch is fine. Okay. So we're going to click check on that. All right, cool. Great. So now we made that hole. That's going to be where the rod is going to go up through. Okay. And now we need to make like a little portal for the nut. So I'm going to click this face, which is where that portal is going to come from. Okay. So what I'm going to do first is I'm going to go to the center line tool. I'm going to go and do what I did before and grab the midpoint of that edge. We're going to go vertically up from there. And then now we're going to go and do the drop down, or if you're going to select the center rectangle. So if you don't have it selected, you're going to do, instead of the corner rectangle, do the center rectangle. And then we're going to do we're going to do square from there, and then we're going to drag it down to the edge. Okay. Um, and then we're going to put the dimensions. Everyone's going to use the same dimensions for this because I'm going to give you all the same nuts. So you're going to do 0.45. Okay, that's like a little bit bigger than like the width of the nut so that you could put it in there somewhat easily, but it still doesn't rotate when you try and screw in the thing. You could do this a number of ways. You could do threaded inserts for this, but I thought this would be kind of yeah maybe easier and they wouldn't pull out. I'm always worried about the threaded inserts pulling out, but maybe that's just me. So zero point 0.3 for that one. And yeah, that should be it. Okay. So now really we just need this to go slightly past the hole that we made, at least, the nuts kind of diameter, if you wish, past the nut, past the hole. So I'm just going to go extrude to cut, and we're going to do this. Oh, no, don't need up to next. We're going to do blind, and we're going to do, where does 1 inch, not two, where does 1 inch get us? Yeah, so again, not really even measuring this, but oh, enter. Okay. And yeah, I would say that comfortably gets us there. So that's fine. Yeah, actually, we'll make it a little bit smaller, 0.75. That should definitely still do it for us. And that way, we don't have to worry about it being like that far deep to like grab with some needle nose to get support out. But you could probably get away without generating support. But we'll keep it off. We'll keep it off. We'll try at least and keep it off, and it should work out fine, especially since we've widened that hole. Okay. So we're gonna click check on that, and that looks pretty good. So it gives us a place for the nut to go, and a place for the rod to go up in there. All right. So we're gonna save this. We're gonna save it as oh, not part two. We're gonna save as for video underscore one because I might screw this up. Saving that. Okay, and now we're gonna go file, save as. We're gonna save this as an STL. Okay. Uh, and then we will go about printing it. Okay. So we're for video underscore one. Cool. Awesome. Yes. Bodies. Okay. So, as far as printing this is concerned, I printed mine on the printers that are in the back of the fluids lab. Those are kind of crappy printers. So I've talked to the guys at the Ideas Hub, and they'll be likely be able to handle the volumes that come in for this. I think that'll probably change if we end up having like 80 students for this lab in the future. Who knows? Maybe we grow in the future. So as of right now, you'll have to ask me in person as to whether or not every single person is going to have a Weir to themselves, which means every single person has to print a different profile, um, or if it's going to be one per group. There's definitely going to be a lot of individual characteristics to this lab, but I might have you do certain parts as a group, including designing the Weir, just so that the print volume is less, and the print volume will be less because your weirs will be much smaller than this. Mine is 4 inches. So again, you'll use your own dimensions here. Yours are going to be much smaller. But anyways, yep, on to the next step, which will be handing this in to be printed. Once you open up a browser window, so yeah, next step is to open up a browser window. And then what we're going to do is we're going to go to help.temple.edu. So you can go to the client portal home. Okay, so as you can see, right now I am not signed in. Okay, it prompts me to sign in. Okay, what I didn't know until very recently, they changed the way they do this, but as I speak to you now on the 20th of February 2026, it looks like this. This will change probably because it often does. I'll come back and not exactly know how to do it, but what we're going to do is I'll go back to explain that. So we're in the service catalog page at client portal at help.temple.edu, as you can see the URL. Um, we're going to go to school and college services. We are a College of Engineering. Okay. And as you can see, if I don't log in, there are 10 services. Okay. But if I quickly sign in, yeah, that's my stuff. Maybe I'll blur that. Anyways, it signs me in, and now I suddenly have 11 services with 3D printing going to the top. Okay. So that confused me for a minute. Before the client portal would just kind of auto log you in when because my email is already open in another window. So yeah, usually it would automatically do that in the past, but now it doesn't somehow. So, anyways, I'm going to go to engineering 3D printing. Okay, we're gonna go to Anthony Bohm. Okay, that's me. Blah blah blah. That's the focal that I'm allowed to charge under. Yours will probably read something different, or maybe it'll read the same if you're in mechanical. I'm not quite sure. Preferred method of contact. We're gonna say email. Okay. And we're gonna go short description. This is spell that right. This is a Weir for Fluids Lab. That's probably all you really need to say. I've warned them about this, so they should know what that is. Okay. Is a consultation needed? No, shouldn't need one unless you want to talk to them about it. Quote only? No, you want them to actually print it. Feature on social media? Yes. So you're going to say other, and you're going to say Fluids Lab. Oh, you know what? In the description, this is a Weir for Fluids Lab. I've warned them about what the materials should be, but you could say PLA, 20% infill. Okay, that's like how dense it is on the inside. Uh, uh, two walls. I mean, that's what I did to print these, just because it doesn't use a whole lot of material if you print with those settings, or whatever, or what is convenient. Okay, that just lets them know that you want the PLA. Okay, really, full disclosure, it'll work with any printer, but this just lets them know that they're gonna print it out of that you want them to print it out of the cheapest material that they have. You could say even PLA or PETG. Okay, that's pretty similar to stuff Coke bottles are made out of, or the plastic ones. Obviously, glass ones are glass, but all right, yeah, that should be all you need. Apart from your file, so you go to browse. I'll go to home, and I'll grab the Weir for video and open. Okay, and then you would push submit. I guess I could do that. I don't really want to like bother them. I already printed this, so I don't really want to bother the IdeaSub staff with printing an extra one now. So I'll just pretend I hit submit, and that's all you really do. It'll probably bring you to a page confirming your submission, although I again rarely have to submit a ticket here. Yeah, basically that is all for this tutorial. Yeah, the rest of these videos will show you the rest of the lab.